Autocorrelation means how much today's value is related to past values of the same thing. Think about stock returns or correlation numbers. If today looks similar to yesterday, we say autocorrelation is high. If today looks very different, autocorrelation is low. In simple words, autocorrelation measures memory in data. It asks one main question: does the past influence the present? In finance, this concept is often studied using time series models like ARCH or GARCH. But don't worry about the complex models right now. The core idea is very simple. We are just trying to measure how strongly values are connected across time. If values keep following recent patterns, we observe stronger autocorrelation. If they move randomly, autocorrelation becomes weak. Now let's compare autocorrelation with mean reversion. Mean reversion means values tend to move back toward a long-term average. Autocorrelation, on the other hand, means values tend to continue in the same direction as recent history. So remember this clearly. If mean reversion is strong, autocorrelation is usually weak, because one pulls values back while the other encourages continuation. Here's a simple example. Suppose the mean reversion rate is 70%, and the one-period autocorrelation is 30%. Together, they add up to 100%. This shows the balance between two forces in financial data. One-period lag autocorrelation compares time t with time t-1. The formula uses covariance in the numerator and standard deviations in the denominator. Covariance tells us whether the two periods move together, while standard deviation adjusts for scale differences. The final result is a correlation value that lies between -1 and +1. How do we interpret this number? A value close to +1 means perfect persistence. Values move together strongly. A value near 0 means there is no relationship. And a value near -1 indicates opposite movement. For example, if correlation values across days move from 0.4 to 0.45 to 0.43, they are moving together. That means covariance is positive, so autocorrelation is positive as well. Finally, let's understand lag. A lag simply means how far back we look. A one-period lag compares today with yesterday. A two-period lag compares today with 2 periods ago, and so on. As the lag increases, autocorrelation usually decreases because older data has less influence on the present. This gradual decline is called the decay of autocorrelation, and it is a very common pattern in financial time series data. So to summarize, autocorrelation measures how much the present depends on the past. It behaves opposite to mean reversion, and it usually weakens as we look further back in time.